to our second lesson under trigonometry in our mathematical lessons. So today we're going to continue looking at trigonometrical functions, and of course last time we looked at quite a number of things, and today we're going to pick it up from there. Okay? In trigonometry, there are 6 trigonometrical ratios that relate to angles. There are 6 trigonometrical ratios that relate to angles, and those are the ratios that we're going to look at today. We're going to discuss all those today. Now, remember from what we looked at, we said that this 360, okay, this 360 degrees, this 360 degrees has got a 40 degrees that cuts the cave, okay, and under this we're going to explore more aspects. And here we're saying that the right angle triangle can be formed from initial side, which is the x, okay. So this is the x. Remember, this is line x, the x-axis, horizontal line. Now, when the x is formed, the x side, there is also a terminal side arrow. The terminal side arrow here, okay? This arrow, where arrow is the radius and hypotenuse of a right triangle. So this is also called the hypotenuse, okay? It's also called the hypotenuse. We're going to look at more on that later. So it is the hypotenuse of the right triangle. Okay. Now, when we go to that, you actually see that here there will be a curve. Okay. There will be a line, and of which this line we have here what we call a 90 degrees what? A 90 degrees angle at the angle what? 40 degrees angle at the corner there. Now, let's look at Pythagoras theorem. Okay? Pythagoras theorem. Pythagoras. Okay. Theorem. Pythagoras theorem. Okay? So the Pythagoras theorem tells us that, the Pythagoras theorem tells us that when you have certain angle, we multiply 2x plus y squared is equals to r squared. Here, this is our y. Okay? So for us to find those angles, we need to multiply by that. In other ways, we are saying that we multiply this by. So to find r, what we're going to do to find the hypotenuse, we are going to say r is equals to x, okay, x squared plus y squared. For us to get this r, we are going to square root both sides, okay? Square root both sides, and our r squared is gone, and we can find for our r. Now, the theta, this here, is what we call theta, okay? So today I want us to introduce this, alright? This symbol, some of you already know it, it's called theta, okay? Theta, it is called theta, okay? Now, theta is used to label a non-right angle. So theta is used to label a non-right angle. So here, this is not a right angle because it is what? A right angle is 90 degrees. So here, there is a theta there because it's 45 degrees. But here, you cannot put theta because it's a 90 degrees angle. Okay? Now, the six functions that we talked about, what are they? Okay? The six functions that we talked about, six functions, okay, 6 functions, you have 1, sine, okay, sine, which is written as sin, okay, sin. Then there's the second one, which is cosine, written as cos. Then the third one, which is written tangent, which is a tangent, and is written as tan, okay. Then we have what we call a cosecant, which is written as cosec, okay. Then we have what we call secant, which is written as sec. Then we have cotangent, okay, cotangent, which is written as cot, okay. So these are the 6, trigonometrical functions, okay. These are 6 trigonometrical functions that we'll be able to build. So we've got a sine, which is written as sine, a cosine, which is cos, tangent, tan, cosecant, cosec, secant, sec, cotangent is cot, okay. So these are the abbreviations that we are going to be using throughout this course, and you do not need to miss out, okay. You do not need to miss out. Now, let's proceed from there. So if that is the case, if that is true, then we are saying that if what we discuss is true, we are saying that here there is no theta. These are non-angled functions. There are no angles there. Okay, remember we talked about theta. Theta is not there. So let's now include theta and see what it is going to come to. Okay, so we are saying one sine theta, okay, sine theta is y over r. Remember, we already have this. Okay, let me just bring it here so that you are able to remember it. Here we're going to p, y, x, and r. Okay, then here we've got our theta, and here we've got our angle there. Okay, so sine theta is given by, that's y over r. And what is our y? Our y is the opposite side. Okay, the opposite side, opposite. Y is the opposite over r hypotenuse. Then 2 cos theta. Cos theta is given by x over r, which is equal to adjacent over hypotenuse. Let's hope you're following. These are very simple concepts to understand. Then we have what we call a tan theta. Okay, a tan theta. Tan theta is given by y over x. Okay, so tan theta y over x, and this is opposite over adjacent. Okay, opposite over adjacent. Now, these are the 3 functions that we have. Okay, these are the 3 functions that we have, and the reciprocal functions. Now we have what we call the reciprocal functions. The first 3 are the main functions. If you've seen, the The first three are the main functions, and the last three are the reciprocal functions. Now, the reciprocal functions, okay, we have the three of them. We have got 4, right? We have cosecant, which is given by r over y, okay? R over y, which is this, which is equal to sine theta, okay? You saw what is happening here. So, r sine theta, okay? Sine theta is y over r, opposite over hypotenuse, okay? So, cosecant is equal to sine theta, and 5 seconds, okay? So, this is theta, right? Cosine theta, then this is sec theta, okay? Cosecant theta, then secant theta is equal to r over x, which is given by, okay, which is given by cos theta. Now, these are like rules, okay? These are like rules, and the more you get these rules, the easier it becomes for you, okay? Cosine theta, then we have got 6, we've got the cotangent. Cotangent, the cot theta is given by tan theta. Now, the three of them, these ones, are called reciprocal functions. Reciprocal functions. Reciprocal functions. Now, the difference between these functions and these functions is that these functions do not have a theta. And a theta is used to measure a non-right angle triangle. If it's not a 90 degrees angle, then you are going to put a theta because you want to find the other sides of the angle. Okay? Now, so you may also recall something called SOHCAHTOA, all right? You may also recall something called the SOHCAHTOA. Now, SOHCAHTOA is something that you may recall that may help you to remember. Okay, those things are quite a lot, and it may be a bit cumbersome to remember everything. So SOHCAHTOA is going to help you remember. How do you use SOHCAHTOA? So, of course, we know that SOHCAHTOA, so it stands for sine, okay? Sine, which is equals to opposite over hypotenuse, all right? Hypotenuse, all right? Then car is equals to cosine, which is equals to adjacent over hypotenuse. Hypotenuse. Okay? Then we got tan theta, which is equals to tan theta. Tan is equals to opposite over adjacent. Now, if you've got a right angle triangle, you've got a right angle triangle like this. If you've got a triangle, of course here you're going to say this is an adjacent, this is opposite, and this is what? Hypotenuse. Okay? So, if you've been given A, B, you can find the A. If you can find C. Okay? So, without wasting much of the time, let's try to explore the values. Okay? Now, for example, if this is true, then what we are saying is that if this is true, then what we are saying is that, for example, e.g., let's look at an example. Okay, let's look at an example. e.g. 1. So we have if you have, for example, let's have this angle, okay? If we've got this angle and we have maybe 5 here and 12 here, okay? Okay? So then we're going to say find this is the x, right? So the question will be find x. We already know that x is the opposite. So the tricky part here is, of course, your first thing is to identify the angles. Once you identify the angles, it will be very easy for you to put in place the answer to your solution. So, we use the Pythagoras theorem, and we know that in Pythagoras theorem, this is our x, this is our y, and this is our r. Okay. So since we already have this and that, what we do? We're going to say x squared plus y squared is equals to r squared. So since we replace our x, we don't know what our x is, we know what our y is. What is our y? Our y is, of course, here in this case, we know that our x is 5 squared plus our y. What is our y? Our y we don't know. And what is our r? Our r is the 12. Okay? Our r is 12. So what are we going to do then? We're going to say collect rectangles. This one will be 12 squared, then this one will move to be minus 12 that. Then this will be what is the 12? 12 times 12. 12 times 12, of course, is 144. Then 25. 5 times 5, okay, 5 becomes 5 times. 5 times 5 is 25. So to get rid of this, we're going to introduce a square root, okay, and our square root, what will be our answer? Our answer will be, of course, it will be this, 165, 169, x will be 13, okay? That will be our answer. So in case you've been asked, do not fail to find. Now, let's look at example 2. Now we want to find the angle. Okay, we want to find the angle with the same results. What about then if you say this angle, we want to find the angle, okay? We want to find the angle, we want to find this is 12 and this is 5, of course. Here is a theta because it's not a right angle triangle. There as usual. Then this is the x and this is what y. Okay. So what do we do? Okay. So first of all, we need to find we can find the value of the sixth trigonometric function. So the question, what is the question? So the question is, find the value of the trigonometric ratio of angle, this angle here. Okay? You want to find the trigonometric ratio of this angle. Now, the trigonometric ratios of this angle, we have to now replace. Now, let's say Sine theta, okay, sine theta, we want to find the theta. That's what we are saying. We are saying, find, the question is find the, okay, find the length, okay, find the length of the, find the value of the geometrical ratios. Find the values of the trigonometrical ratios, okay, of angle theta, this angle here. So we want to find the trigonometrical ratios, and we know that sin theta, of course, we know that sin theta is given by opposite over hypotenuse. What will be our answer there? So, which one is our opposite? Our opposite is what? 12 over 5. Okay? 12 over, since here we've already found what the hypotenuse is. Our hypotenuse is 13. We found it in the previous example, our hypotenuse is 13. So to find the angle, the size of the angle, we are going to say 12 over 13. That's the size of the angle. Then when we go to cos theta, our answer will be, we know that cos theta is adjacent, okay? Adjacent over hypotenuse. So our answer will be, of course, adjacent is this one. So 5 over 13, okay? That's our answer. Then we go to tan theta. We know that tan theta is also opposite over adjacent. Therefore, our answer will be 12 over 5. Okay? As simple as that. So, here, these are our things. So, the exercise I'm giving you now is find the cosecant, find the cosecant, find the secant, okay, find the secant, and find the cot, okay, find the cot. Now, remember, the answers for these questions are going to be required to be filled here. If you don't solve them when you own the quiz, you will find them somewhere in the quiz. So it's better that you do them now, so that once you have them in the quiz, you just go and fill them according to the way you have learned. So thank you so much. Until we meet in the next lesson, when we are going to look at other components of this lesson. Goodbye.